So let's discuss states, Corda states, the states section of our Corda distributed application. So each node only sees a subset of states on the ledger. So with Corda, privacy is the most important requirement for businesses on the Corda network. Yet traditional blockchain architectures share every fact with every participant on the ledger. There is no privacy beyond the anonymity of the public keys. And with Bitcoin, if you take a look, it's quite anonymous. All you see are the public keys out there. If you go on to any blockchain explorer and look at Bitcoin transactions or Ethereum transactions, you never see a name. You just see that anonymous public key. Corda, on the other hand, only shares information on the need-to-know basis. So here we have a diagram where each of the big gray circles represent a party on the network or a node on the network. And in our case, we have a network of 5 parties, and the nodes are called Alice, Bob, Carl, Demi, and Ed. And we can see here the smaller colored circles represent the on-ledger facts known by each party. So if we take a look here, Alice and Bob only know this fact, fact number 1. So this is the ledger entry that's visible to Alice and Bob. And if you take a look over here at this matrix, you can see here Alice and Bob know about fact number 1. That is an entry on the Corda ledger. If we look at entry number 2 is only known by Carl and Demi. And if we look over here, entry number 2 is only known by Carl and Demi. So these are 1 and 2 are entries to the Corda ledger. But notice the entries are distributed throughout the nodes on the Corda network, different from Bitcoin and Ethereum, where every node contains a full copy of the ledger. This distributed ledger ensures that the nodes are only aware of transactions to which they are permissioned to know, or that they are entitled to know. And again, we can see again, Carl and Demi also share fact 3, and we can go on and on through this matrix. Carl and Ed have 9, 4, and 3. Ed and Alice have 7. So take a look at these. Well, this looks like a Venn diagram, so you can see the facts that all of the nodes have in common, and we can also see it here listed on this matrix. And let's talk about a little bit about the Corda State API. So the Corda States have a library or an existing class called Party, and we'll take a look at that. That is, it's available as a import through Java or through the Kotlin language, and then also contracts or the ledger through contract states. The IOU state class implements the contract states. We'll actually see that. So we see, especially for those of you that know Java, we know about interfaces and how different classes can implement interfaces. Well, that's what's going to be happening here with Corda. So we have our IOU state class, which will implement contract state. And so either through the Kotlin language or through the Java language, it does the exact same thing, implements an interface. We can see here the properties. We have an issuer, which is of type party. We have an owner, which is of type party. And then we have an amount, which in this case is of type integer. And then we have our participants, the issuer and the owner. So here, this means I'm going to do a demo. So let's take a look at our IOU state. So I moved back to our solution that's opened up here in IntelliJ, and I moved down here to our contract state, and we can see our contract state class. And you can see here we are importing some libraries. And if we take a look here, even though this is Kotlin, we can see we are implementing. So we see the belongs to or implements the contract class. So state implements the contract class. You can see we have our amount here declared, and we have our participants, lender and borrower, that are of type party. So party, and we can see up here, is imported with Corda. It's an existing library or an existing class, which we will use. And here we'll also be defining an amount that's paid. We will be getting the lender and the borrower. And then we can see functions here. So we have our class, just like in Java, and methods are called FUN, or functions in Kotlin, same thing. We can see here that we have a payment function, and we also have a new lender function here. So this is how the states are implemented in our CorDapp. And also, I encourage you here to read through these comments. These comments are quite good. They make a very thorough explanation of what's going on here. And if you look through this, if you are inclined for programming in any way, you can see how this makes a lot of sense and how it's quite straightforward. So to summarize our states section, states again are shared facts that are distributed on the need to know basis. So we can see with Corda, all of the ledger entries exist distributed throughout the network. There is no one single ledger that's on every node. The shared facts are represented using states. Those are instances of classes implementing the contract state interface. The contract state classes should have participants who will be notified of updates and additional fields to capture shared fact information.